Hi, and welcome everyone to another Keptn webinar. And today I'm very honored to have Julius with me. Hi, Julius.
Hi there. Thanks for having me on, man.
Yeah, it's really a pleasure. Julius is a co-founder of Prometheus and the founder of PromLabs. And today he will show us how to build advanced SLIs and SLOs with PromLens. And we will be using these SLIs and SLOs, of course, in Keptn. I will be doing a little bit of introduction to set the stage for Julius. I will talk about why we need it. And then I will hand over to Julius and he will share how to really build advanced SLIs with PromLens. If you have any questions, it's the first time that we are streaming directly to YouTube. Normally we are on Zoom, but we decided to go directly for YouTube this time. If you have any questions, please put them in the YouTube comment section. I will be actively monitoring this section and I will forward the question after the presentation of Julius. I will forward the question to him, or if you have questions on Keptn, on SLIs in general, also put everything you want to share or you want to ask, put it in the comment section, and we'll be happy to answer later on. So with this, I will be jumping into the first part of the presentation, give you a little bit of background. Julius, I will just put you to the backstage and I will bring you back up to the stage really soon. So see you in a minute. Well, let's start. Why do we need SLIs and SLOs? What is it actually? I've not even explained it yet, but let's start a little bit earlier. Actually, let's start with a common CI/CD pipeline. This is really more a CD pipeline, I think. But when we're thinking about these kind of pipelines, they start with building, they start with deploying, we want to run some tests, and we want to make sure that our microservice, that our application that we run into production, that it really satisfies a given quality criteria or more criteria actually. So we need to have some kind of approval. And typically this is done by analyzing the time frame of the test period, by taking a look at the performance. Is it slower than the previous run? Is it equally good? Is it faster? Why is it faster? And we have to take a look at a lot of data, and we have to separate the data that is really affected by this test run and other data that's usually just some, let's call it some noise in our environment. So we really have to make sure to take a look at the right data for this approval process. Because what we don't want to have is that we ship something into production that is actually not a good build. So we really want to make sure that everything we want to ship in production does satisfy some given quality criteria. And this process usually takes quite a while. But what can we actually automate in this process? So the thing is here that really this manual approval takes a lot of time. So we want to automate this manual approval process. How can we do this? We could actually gather the metrics automatically. For the test period, we can automatically generate a score. And based on this score, we can automatically make a decision if we want to promote it to the next stage, if we want to release it to production, or if we want to roll it back or hold it back in this stage, or even roll it back to the previous version. And this can be done automatically. In Keptn, we also call this a quality gate. And this mechanism should not be done only once, but this should be done continuously. We want to have continuous validation of the quality of our applications or microservices. And we, of course, we need some data that we want to evaluate. So if we have this concept, we can put it in our CD pipeline. And the actual quality gates, the quality criteria, we define them as service level objectives. We call them SLOs, and I will share a little bit more detail just in a second. But let us just think about the concept that I just explained, how we can put this into our CD pipeline. So we still do our building, our testing, but after the tests, we are triggering this quality gate. And basically the quality gate, what it does, it will pull the metrics, we will pull the data for the testing time frame. We will pull the right data that is labeled, that is tagged, that we already know which data is affected by the tests that we have been executing on our application that we want to deploy or that we want to release actually. So we are doing this quality gate evaluation. We are fetching the data and we are validating service level objectives one after the other. And this whole process can be done automatically, coming up with a score. And based on the score, we can even either give it a thumbs up or a thumbs down. And the whole process can be now really decreased in terms of the time it takes from a couple of minutes to around 1 minute, because the only thing what we have to do is automatically fetching all the data, doing the evaluation of the data, and then making a decision. And this can be done with Keptn quality gates. So how does Keptn quality gates work? So first of all, we are using two prominent concepts of the site reliability engineering community. There is also a great book on this, the SRE handbook, it's called, or Google SRE book. It's actually from Google engineers, and you will find it online. You can read it online for free. And I will just explain two concepts of this SRE community. The first one is service level indicator, and we can think of this service level indicator really as a metric, something like the error rate of a login requests. For this metric, we want to define a service level objective. And this objective is some target for the indicator, something like the error rate of the login requests must be less than 2%. And we can even say within the last 15 minutes or within the last test run. So we can even give it a time frame. And with these two concepts, we can already build a strong quality gate because we know where the data is coming from, and we can define a target, an objective for this data. And in Keptn, we already have some metrics included. We already have service level indicators for the red metrics. I always mix up the different characters here, but it's basically the error rate, the response time, and the throughput that is already included. These are the basic metrics. But what if we want to have more? This is where Julius will come into play. But how can we use already these red metrics, or how are SLIs and SLOs, how will they play together? So let us take a look into Keptn, how the SLI and SLO based evaluation is actually done. On the left-hand side, I have a very simple SLI file. The SLI file in Keptn really defines the name of the SLI and the PromQL, how to fetch this SLI. And on the left-hand side, I have, for example, the error rate, the number of database calls, or the response time for the 90th percentile. And we will see just an excerpt of a PromQL here, how this is done internally in Keptn, or how you would define it that Keptn can use it. And in the SLO file, we take the name of the indicator, and we can use this indicator name and add an objective, a target for this indicator name. So for example, and I hope you can see also my mouse moving here, for example, the error rate, I want to define an objective for my error rate. For example, it has to stay lower than 1%. That's basically what it says here. It has to be lower or equal than 1%. So with this, I can define a criteria, or for the number of database counts, the criteria is it's only allowed to increase by a maximum of 2% to the previous runs, run or runs. That's just how you want to define it. And with this, you can make a very strong quality gate. You can mix different criteria. You can have a combination between relative thresholds and absolute thresholds, something like we have here. We allow it to pass if it stays within an increase of 2% to the previous runs. If it does not stay within this increase, Keptn will go ahead and evaluate also the warning criteria that says it has to be, the number of database calls has to be less or equal than 10 for this particular microservice that is under test for the particular time frame that we are evaluating, usually for the time frame of the test run. this is all orchestrated and triggered and executed by Keptn. And you can define this quality gate in plain YAML, and you will define and add this quality gate to Keptn. So how can you execute it? Either directly in your CD pipeline orchestrated by Keptn, or you can also do it via the CLI and just send an event to start the evaluation. And what the Keptn control plane will do, it will reach out to the providers of the to the data providers. In our case, for example, Prometheus will fetch the data and will then start to evaluate each objective of the SLO file, coming up with a total score. And based on the total score, that's also written here on the left-hand side. I get a layover here, but based on the total score, it will basically give you a thumbs up if the quality score is high enough that is allowed to move to production, or it will give you a thumbs down if the quality score is not high enough and it will be rolled back or held back. If you're not integrating Keptn in your CD pipeline, or you're not using Keptn as the CD orchestrator, then you just get back the result and you can do whatever you want to do based on this result. The important thing is here that you really have an automated way to evaluate the quality criteria, and this is based on SLIs and SLOs. And as said, a couple of SLIs, they are already defined in Keptn, but there might be more complicated SLIs that you want to write. And writing PromQL is actually not that easy. So I will be handing over now to Julius, and he will explain us how to actually build advanced SLIs. And yeah, the stage is all yours. Let me just put you back on the stage here. And here we go.
Yeah, thank you, Jürgen. Great explanation. Yeah, so let's look at one example of a bit more of an advanced SLI and how we might go about building it. We will see some challenges during the PromQL building process, and then I'll briefly talk about PromLens, a tool by my company PromeLabs that aims to make building of queries simpler. So just as an example, if you want to get a bit more of a complex SLI than the ones that are built into Keptn, let's imagine we want to look at the 500 error rates of a given service that we care about. And we want to aggregate that error rate over multiple different service instances of that demo service, but we want to still split it up into different combinations of paths and methods. So we want to check each of those individually if their error rate percentage is pretty large for that combination. But then we want to introduce a further complication where we want to say we only care about such method and path combinations on our service that get at least a given amount of traffic, because otherwise you might get like one 500 error and almost no good requests, and immediately you have a higher error percentage. So just a kind of example how to add some conditions to those SLIs. So this should be easy, right? As Jürgen already mentioned, PromQL is not always super easy. It can be a bit tricky, a bit tough to learn, but also once you know how it works, it's not always super easy to actually work with it and build queries in the interface in Prometheus. So a query that I just described could look like this. Without going too deeply into the Prometheus query language, I'll just describe on a high level what it does here. So on one hand, we are summing up the 500 error rates over all of the instances in our service, but still keeping method and path labels. They are on this metric here, but we don't see them. And then we're dividing every path and method 500 combination by its total rate. So we're getting a ratio of the 500 errors divided by the total rate for the same combination for that path and method. To get from a ratio to a percentage, we multiply everything by 100. And now we still wanted to add that additional criterion to say we want to exclude any path method combinations with a total request rate that is not at least 1 per second. So I'm doing that down here with this AND binary operator, set operator, just excluding combinations that don't at least have that high of an error rate. So what can go wrong? First thing that can go wrong building this kind of expression is that you don't get any query output. The result in the table view in Prometheus will just be completely empty, and you don't know why. So this might actually be totally fine. So in the case where there are no, where there are just simply no expressions that any path method combinations that match any total rate that has at least one request per second, you will just not see any result. But there could be many other reasons. So, for example, you may be selecting an incorrect metric name. Maybe it has changed over time. Maybe it was correct once. Maybe one of your label matchers, like the job, demo, or the status 500 is broken in some way. Maybe the label names are not quite as you expect. Maybe the label values aren't. Maybe you are calculating rates over a too small window. A rate needs at least 2 data points to exist under a time window to be able to calculate a rate. So that could be one thing where it just produces empty output. Maybe you got the binary operator matching incorrect here. So if you didn't have any modifiers on this binary operator, you would also just get an empty result. So you see like a lot of little things that can create anxiety and are tough to get right. And you kind of need to know what underlying data you're working with at each of these different sub-expressions to be able to formulate the right binary matching correctly, and so on and so on. So there's one more issue. For example, if you create an error somewhere in a PromQL expression, this is a shorter one just to demonstrate this, you will get an error message saying that something is wrong somewhere in this expression, but it's kind of tough to figure out where exactly this problem is happening, and then what is even wrong. What do certain constructs in here mean, like group right and ignoring and so on? It doesn't really help you much. There's no syntax highlighting either. So it would be nice to have something that is a bit more helpful, right? Also, even if you get your queries correct initially, metric names change over time, label names change over time as people change the way they monitor things, the instrumentation within services, and so on. So even if you do have something correct initially, it's nice to have a tool to be able to debug queries over time, whether that's an alert query, a dashboarding query, or an SLI in Keptn. Also, there's not real autocomplete syntax highlighting, deeper code intelligence, and so on in the built-in Prometheus UI. So enter PromLens. PromLens is a query builder, analyzer, and visualizer for the PromQL query language. And you can try it out on PromLens.com, but it's really meant to be deployed on-premise, very simple Docker installation. You run it, you point it at your Prometheus server, and voila, you get a better UI for working with PromQL. So let's just have a very brief look at some of the features, and then I will actually demo working with it and building that example expression that we just looked at with PromLens. So first of all, it does have a nicer query editor built in that has proper highlight, auto-completion, contextual auto-completion especially. It also has a built-in linter that can show you a lot of common query errors right underlined in the editor. The core aspect is that it really shows you the structure of each query that you type and shows you at every subquery what results you have, how many results, what are the different label names, and how many different values are there for every different label name. So 8 for the mode label here, for example. As I said earlier, like this would show you really quickly where you actually produce empty results somewhere in your expression. So it would be really, really easy to pin down the problematic parts of your query with this kind of tree view that gets generated out of your query. For every different type of node, PromLens can also just visualize it. So show tables and graphs and so on. It can also show you where exactly certain PromQL errors are happening in that tree view. So you get if it can't find them with a linter yet and they actually happen during the execution, you can pinpoint it in this tree. And then for every type of node that you click on in this tree, it can visualize a bit for you or explain what exactly is happening. What is this node doing? In this case, it's a binary operator. It will show you how the left elements, the time series from the left-hand side, will match up correctly or incorrectly with the time series from the right-hand side. So this helps you get binary operators correct. Not everyone will know all the syntactical constructs of PromQL. So PromLens also has a full form-based editor built in. You can create any PromQL query just by using a form editor if you really want. And this is inline. So you have this tree and you can just switch any node to a form editing mode and then see what the different aspects of that subquery actually mean. And you can change them and apply them. Similarly, you can actually jump into any subnode and edit it directly as PromQL as well, if you're comfortable with that. And yeah, so let's actually just, without looking further at GIFs, let's just jump over to PromLens itself and start building that query that we saw earlier, just so you get an impression of how you would work with this tool and what it feels like. So I'm now on PromLens.com. This is a demo deployment of this that, it's currently pointed at my demonstration PromLabs server. So there is exactly the data that we're expecting for the query that we looked at earlier. So I probably, typically you start out just selecting some data. And
sorry for,
yep.
Is it possible to make it a little bit bigger?
Yeah, that's a very good argument. Is this better?
Yeah, it's already better. Thank you.
Or I zoom in one more step?
I think it's fine. Thanks.
Okay, great. So how people typically start is just, hey, I select some data. And in this case, this is the actual request count I get over my service. And then it has all these different labels, path, status, method, and so on. And already it actually suggests me, hey, this is a counter, so you might want to add a rate over this. So I'm actually just going to follow that and update the text view up here, just follow that recommendation. Now I probably want to get, at first, let me just get the status 500 error. So I could actually just use the autocomplete up here. And now I have only the bad ones, only the 500 requests. And I want to get those not for every instance individually. In this case, I can see all the 3 different demo service instances individually. I want to aggregate that away. So I could do that over here. I could also actually just click on Add Some, and then I could use the form builder to say, I want to preserve all labels except the instance label. I want to aggregate that away. So, oops. I mistyped it. Instance. See a preview up here, apply the change, close the form editor, and now we get the 500 error rate for every path and method combination. The job is always the same, so we can ignore that. Great, so that's good. Now I want to divide that for each path method by the total rate. So what's the total rate? We could actually start building that as a separate query. Maybe I'll just copy this over here. The total rate would then be all the different status codes. And I then actually want to get rid of the status code dimension because, I want to sum over all the different status codes. Currently, it would give me this per status code. So here in the without, I will also say I want to do without the status code. Oops. Close that. Great. So that is good. Now I could add a binary operator, say, hey, I want to have a binary operation between my initial query. I'll keep it naive for now and just say like sum divided by. And I can actually just drag this expression from the bottom over here. I hope I'm not actually making it more confusing right now. But right now I'm trying to divide this 500 error rate by basically the total rates. And I see already I get 0 results here in this binary operator. Although I have 4 results on the left-hand side, right, for all these path and method combinations, and 5 results on this one. There's an additional path on the total side that doesn't have any 500 errors, so it doesn't appear in these 4 results. So why doesn't this binary operator do anything? Let's explain it. Oops, I think I broke something. Yay. Okay. Interesting. So that's the case I need to check. Let me get there again quickly. So we have that's the unplanned parts.
But that's the cool thing, that it's really live. So we can see it was really alive, or it's really interactive.
Yeah, you can imagine though that I will fix that bug very quickly now. Thought I'd gotten rid of those. Okay, so again, like this, and I will here on the right-hand side, I want to get rid of the status code. Yep, and okay. Interesting. I will try. I won't click there again. I have to see what's actually up there. So now I will actually maybe just look at the 2 sides here. So one reason why these don't match up is because the left-hand side still has a status code label. And by default, this kind of binary operator matching would try to match exactly identically labeled objects from the left and right-hand side. But all the left-hand side objects have the status 500 label, all the right-hand side do not, so nothing will match. So I can actually just tell this thing to say, hey, only match on, or actually the opposite, ignore some labels in the matching. So I want to ignore the status matching. And yeah, so now I actually do get results here. For good measure, for cardinality reasons, I could add a group left here. I don't think I actually need it here. So you can see I jump around a bit wildly, like depending on where it's currently most convenient for me to edit things. Like with a form, inline PromQL, I can always switch to that if I want to. I can edit a whole subtree inline. Now, let me just save this link just in case that bug is still online. So if I explain this, yeah, now this actually works. So I can see that the left and right-hand side are paired up correctly for all these different, for the 500 rates on the left-hand side and the total rates on the right-hand side, and it's ignoring the status label. And then there's this additional non-existent API endpoint that only produces 404, so it doesn't have 500 errors, so this doesn't find a match. Okay, so the last condition that we wanted to add, oh, well, there's a couple more things, right? So I wanted to get to a percentage now, just multiply everything by 100. And then I want to get to, I want to filter away the those combinations of method and status that do not at least have 1 request per second. Well, yeah, or more than 1 per second. In this case, I also, again, like the AND has a problem here. It produces 0 results, although I have 4 results on the left and 5 results on the right. And the reason here is, again, the matching. So I do have a status code on the left-hand side, and I do not have the status code on the right-hand side, but otherwise the cardinalities actually match up quite nicely. So all I need to do is tell this thing to ignore the status label again in the matching, and then I should actually get results in the very final query in the AND. So these are the per method path error rate percentages, but only for those paths that have an error rate larger, a total rate larger than 1 per second. So this was just a demo how to work with PromLens. And, it has a couple more features that I haven't shown. Like, the linter will show you where something is broken and so on. Cool. Okay, back to the actual presentation. There's one more gotcha that I haven't talked about at all. So currently, this expression that we looked at outputs maybe no paths at all. Actually, I do have a bug on the next slide here. I will talk about that. But it might not output any paths at all if, for example, there is no path method combination that has more than 1 per second, right? Or it might output multiple outputs. Let's just look at this next slide. It might output multiple outputs. For any, so basically one output for any of these paths that do have a larger than 1 per second rate. And I just got these headings wrong. That's what I meant with the bug. So it will show you. It will show you all the paths that do have a high enough rate, because we're not filtering by the actual outcome value yet. And so basically, sorry, Jürgen, I actually did have a bug in here. I wanted to get into it. So I wanted to get to a state where I actually not have just not as the final output, not have the ratio, the error ratio for each path, but only have it if the error ratio itself is also high enough. So we would have to add like one more filter to the actual query, which I actually totally forgot. But this would be something like, if we go back to this example, we would add one more filter to around everything, saying like, hey, show me the paths that match all these criteria and that have a larger than, let's say, 2% error ratio. And then we get one output. So imagine we had that. So the problem with Keptn is that in those SLI specifiers, it expects exactly one single output number and not 0 numbers or a whole vector of time series of numbers. So we need to somehow condense down that filtered list of method path combinations to a single number. So what could we do? For example, we could wrap the query around all of it and make it such that if it outputs a 0, all those combinations of path method are good. And otherwise, it would produce 1, 2, or 3, like however many bad of endpoint combinations there are. So the way we can achieve that is the following. We wrap the entire expression that we do have, including that last filter that I just ad hoc built in there. We wrap it in a count aggregator in PromQL, and this will count how many output series there are. So this will give us a single number in the end. There is one gotcha though. If there isn't even an input number, because there is currently no bad path at all, then the count aggregator will also create just an empty result, which Keptn will also not be able to deal with. So we need to make sure that in the case where everything is fine, we actually join in using the OR set operator. We join in a default value of 0, and then that will make it into Keptn. And so in Keptn, then we could just have a actual comparison to that output and have some kind of threshold. Maybe if it's larger than 0, we don't roll out further. Great. So yeah, try out PromLens. You can actually try out the demo on PromLens.com. It has a public repo as well. And you can also file issues there. And you can already, it's pretty early on, but you can already get a license and give me feedback. And yeah, it would be really good to see if people use it and if it's helpful for people. Cool. Thank you.
Cool. Thank you so much. It was really great to see how you start from very small and easy PromQL to getting more and more complicated. So really thanks for this. Before we move on to the questions, I would just highlight how to get started if you want to try Keptn or if you want to try PromLens. Or for Keptn, it's keptn.sh. For PromLens, it's promlens.com. And if you want to join the Keptn community, I have listed a couple of links here. I've also listed the integration for Prometheus and the Prometheus SLI service that you might want to install when you're running Keptn together with Prometheus. We are doing this kind of webinars regularly, so please join the Keptn community, join our or follow us on Twitter and join our Google group so you always get updated on when we are hosting another Keptn webinar. So let's take a couple of questions here. So we received a couple of questions. I would just throw them directly at you, Julius. It depends on, I think a couple of questions are more Keptn related. So there was one question, I think you just answered it. It says, do I need to sign up to use PromLens? And yeah, but I'll just hand over the question to you.
Yep, so you can use the free version. So it's not open source, but it comes in a Docker container, which you can run with or without a license key. And without, it has some basic features. So you can manually specify a Prometheus server to connect to at the top and then enter your queries. If you get a licensed version, you can actually connect it to an existing Grafana setup. So it will show you a data source selector at the top where you can just choose one of your Prometheus data sources that are already configured in Grafana. You can also create shared query links. And yeah, there's some other features that are or that will be only available with a license. And yeah, you can go to promlens.com/pricing to see the current pricing. I'm experimenting with it. It's still pretty early on. So if you feel like that middle tier that has a fixed pricing isn't really working for you, just talk to me and we can explore this.
Cool. Thank you. So there is a free option, and yeah, so give it a try on promlens.com. There was one interesting question: can I deploy PromLens with Keptn? I think it's actually made that you can just run it on your local machine, but so from a technical perspective, I think it just runs in a Docker container, right?
Yeah, I mean, like typically you would deploy PromLens even somewhere in your Kubernetes cluster and just connect it to the Grafana. So it wouldn't be something that typically users would deploy on their laptop or so. It would just run somewhere as a very simple service. It's mostly stateless, except for if you have some link sharing backend configured. And yeah, and then it's just a better UI for your existing Prometheus servers.
Cool. Yeah, because then I think, yes, it's definitely possible to deploy PromLens with Keptn. So you can ship PromLens to your Kubernetes clusters also with Keptn.
Yep, that is not integrated. Like you would still have to then in the end like copy a query you built and somehow like paste it into your Keptn config files or something like this. But
yeah, but I think because we had another question, how to add the SLI to Keptn. Yeah, that's exactly the answer. If you write your SLI in PromLens, what you can then just do is you copy. I think the editor that you showed us, it's basically a text editor, so you can copy from there, and then you put in the SLI file in Keptn. Just make sure there are no blank, there are no new lines in there. You copy it in the SLI file, you save the SLI file, and with the Keptn CLI, you just do a Keptn add resource, and you take the SLI file and put it on into your Keptn control plane, and it will overwrite the previous version. Everything is GitOps based, as you know, so you still have the previous version in the history. All these kind of things you still have, and you can just then edit. Yeah, and if you want to run PromLens in a Kubernetes cluster, and the way to bring it to the Kubernetes cluster, you can also use Keptn to deploy it there. You can even have a quality gate for PromLens to check if some of the PromLens internals are fine. The other questions, I think that we covered already. So with that, once again, thanks so much for joining us today. Thanks to Julius, thanks to the audience joining us on YouTube.
Thank you.
Please check out PromLens.com. Give it a try, give feedback, and also check out Keptn on keptn.sh, and check out the Prometheus integration and write your SLIs and SLOs with PromLens. Thanks so much, Julius, and see you soon, and have a great day. Bye.
Thank you.